Hi, in this video I will talk about the planning phase of an experiment, and I will try to focus on the main steps that you need to take in order to plan your experiment. There is more information about the planning phase that you can find in your course book and in its supplemental text material as well. In Swedish, the concept we use for design analysis of experiments is FÖRSÖKSPLANERING. So the Swedish word has a clear focus on the planning part or the planning phase of the field of design and analysis of experiments. And the planning phase is of course very important. But in trying to keep things simple, we can say that we basically have three interconnected phases of the experiment. First, we design and plan the experiment, and then we perform the experiment and collect data, and lastly we analyze the data and draw conclusions. And these three phases or steps are of course interconnected. For example, the experimental design that we pick may come to affect the analysis that we have to do in the later stages. So the field does not only cover how to plan your experiment, it also covers how to perform the experiment and how to analyze the data. But this video will focus on some of the important steps in the planning phase and topics in relation to this. Let's first have a look at this conceptual model of an industrial experiment. And this figure is inspired by a figure in the course book. So a central part of the planning phase of the experiment is trying to understand the process or the system that you will be experimenting on. For example, you need to define important responses or response variables. You also need to understand which factors that you may control during the experiment and which factors you just want to keep constant. You also need to have an idea about potential disturbances that can affect your experiment and try to use some strategies to limit these effects of noise factors on the results. And what we try to do in the experiment is to try to see if we can uncover or quantify causal relationships between the design factors and some of the responses that we have from our system. Here is a 7-step process or a guideline for planning, performing and analyzing the experiment. And these guidelines are discussed further in the course book. In my opinion, the first 4 steps in these guidelines are part of the planning phase. So I will talk a little bit more about these first 4 steps. Let's take a look at the first step with an example in mind. Assume we are in the process of trying to get a paper helicopter to fly as good or as long time as possible. So we are not happy currently with how well it flies and how long time it is in the air. So we want to get it to fly as good as possible. Now, in relation to that problem, we can have a few overall experimental objectives. And Montgomery in the course book, he discusses 5 overall objectives. And these are first factor screening or characterization. So let's say we are interested in finding out which factors that affect how the helicopter flies. We can also have an optimization objective. Let's say after characterization we are interested in trying to get the helicopter to stay in the air for as long time as possible by finding and setting the levels of important factors. We can also have a confirmation objective, and these can occur when the experimenter is trying to verify that the system is behaving as can be expected from, let's say, theory or past experimentation that has been done. We can have a discovery objective, and these can be like, let's say we have a question like what happens when we change the material or explore new factors or settings and things like that. And we also can also have a robustness objective. We can try to set controllable factors at levels that minimize the variability that is transmitted to the response variable by noise factors or other factors that we cannot control. So it's important, first of all, to recognize and state the problem, and also have a clear objective in mind with the experiment that is going to be performed. And the next step is about selecting the response variables. And when we choose a response variable, we need it to really provide us with useful information about how well, in this case, the helicopter flies. And there may be multiple responses that we are interested in. For example, we might be interested in both the, let's say, the average flight time and its standard deviation, or other how well it flies in the air and things like that. Another important concept or topic to consider is the measurement gauge capability. So how reliable is the gauge we intend to use, for example, in measuring, let's say, the flight time. And here you have an example of potential responses that can be used in this case with the paper helicopter. So the responses can be, for example, the average and standard deviation of the flight time of the helicopters, and we also may need to define how we measure flight time, and that can be measured from the time that the helicopter is dropped into the air from the height of 5 meters until it touches the floor. So that is an example of a response variable. In the third step, we need to choose factors, levels, and ranges of the factors as well. And there are factors that we can control, such as design factors that we want to change, and held constant factors that we want to keep constant. And we also have factors that we cannot control. These are uncontrollable or noise factors. And here you have some examples of potential factors. Let's say the wing width and length, center body height, and so on, total width, and so on. So there are, of course, quite easily you can imagine some factors in this paper helicopter that might be interesting to change and see if that affects the flight time. But it is often good to try to structure the brainstorming activity of uncovering potential design factors and other factors as well. And the cause and effect diagram is a useful tool for this. And sometimes in this case, the 8M categories. Here you have machine, method, material, man or mind power, measurement, mother nature, management, and maintenance. These categories can be helpful in trying to structure this brainstorming activity and help you think of factors that you may forget otherwise. I just added some examples here with factors that can be related to each category here. So that's a good advice to use the cause and effect diagram in this process. And factors can also be divided according to, let's say, if they affect the response, if they can be measured, and if they can be controlled. Design factors, they need to be controllable and measurable. And sometimes they will also be proven to affect the response after our analysis. So design factors we can find here, let's say, as controllable factors, measurable factors, but also sometimes, hopefully, factors that can affect the response. noise factors, they affect the response and may be possible to measure. And most of the times they are impossible or too expensive to control. So here you can see that sometimes noise factors affect the response, or many times they do, and sometimes we are able to measure them as well, and that can be useful. And then we also have held constant factors, and these may be factors that we know affect the response, but we are not interested in investigating them in this experiment, for example. And sometimes we also need to prioritize. We need to pick a number of factors. We cannot pick all of them. So then we keep them constant during the experiment, those factors that we do not pick as design factors. We also, in step 3, need to think about levels and ranges. And choosing levels is often considered quite difficult. And we need to be careful not to choose too narrow or too big range, as this may result in some difficulty for us to measure a significant difference in the response. And as you can see in this figure, let's say we have this behavior of the response for variable or factor A, and if we choose a very narrow range between our levels, we may be unlucky in the sense that we cannot really see a big difference in the response. We can also have this situation that we are unlucky that we have a too big range between the let's say in this case the two levels of our factor, and since it doesn't since the response doesn't change too much between these two levels, we may have a hard time to detecting a signal here. The problem is that we normally do not know how the response varies like this. So we don't know the behavior of the response in the interval. And this makes this process of selecting levels and ranges quite difficult. So we need to use subject matter knowledge, or let's say non-statistical knowledge, if it's available. Then we can think about which levels are currently used in the process, if it's a process that is running. And we can also talk to engineers or other process experts in trying to find suitable levels for our experimental factors. And because the choice of factor levels and ranges are riddled with uncertainty, we need to remember that the experimentation is supposed to be iterative or sequential, let's say. So you learn as you go, and you can adjust levels in follow-up experiments. And you shouldn't use your entire budget in one big experiment because of this uncertainty that you have. In step 4, you choose your experimental design. And in doing this, there are a number of important considerations that need to be made. And these are, for example, if you are running a screening, characterization, or optimization experiment, and also what type of empirical model you have in mind in the analysis. Is it a first-order model with interaction terms, or a second-order model? Also, what are your budget allowing you to do? Can you do a full design? Do you need to do a fractional design? And also you need to consider basic principles of experimentation, such as randomization, replication, and blocking. Are you going to have your run order randomized? Are you going to use replicates, and how many? Are there replicates or repeated measurements you're using? And will you use like a blocking strategy, for example, in your design? There will be much more detail about different designs in later videos, so I will not go into much more detail here. But the fourth step is about choosing the proper design for your study. In summary, the planning phase can be viewed as consisting of these 4 first steps of the guidelines in the course book. So you state your problem, you select the response or responses if you have more than one. You choose your factors, your levels and ranges, and you choose the appropriate design. With that, I thank you for listening, and good luck with planning your experiments. Thank you. Bye-bye.